Okay. Hello, everybody. Hello. I made the thing work. It's very good. So, welcome back to our final Monday lecture for COMP1511 this semester. I know, it's very sad. You won't have to get up so early to get here at noon anymore. So, I do genuinely hope that you've enjoyed the course and you've gotten something out of it. If nothing else, not panicking, I guess. So today's lecture, I'm going to go over the exam a bit in terms of what it involves, what sort of questions there'll be, and then we'll do some revision. I've put up the thing for the revision questions, and I can see them here. I won't put them up here for now because I'll do slides, but we'll see how we go. So, first of all, don't panic. The top-rated question here is, should we panic? Answer, no. There we go, I upvoted it. So, it's week 13, right? How crazy is that? We've had 13 weeks together. You've learned some stuff, hopefully. I've learned some stuff, hopefully. So a couple of sort of admin-y things. First of all, there's the My Experience survey. How many of you have already filled it out? There are 66 of you, so I'll be counting. So in your tutorial/lab this week, it would be very good if you could fill that out, or during the break. I'll put a thing up during the break. But basically, the university wants to see what you guys think. Was the course good? Was the course bad? Which things made it good? Which things made it bad? What would you like to improve for future offerings? And so on. So please, please, please do that, either in the break or in your tutor lab today or at home or whatever. Thing number 2, Spots is now running every night because you guys wanted some more instant feedback, and I thought that was a really good idea. So every night at 8:30 now, it's going to run a new round of Spots, rather than just Monday, Wednesday, Friday. So that's pretty cool. You should have a look at that. And in Wednesday's lecture, we'll be going over prizes for the Mandelbrot Art voting thing. There are some very good entries, and the winning ones, I'm very pleased won. There'll also be an AI tournament on Wednesday's lecture. So this won't be like the final, this is your AI mark, but we'll run a round of the spots then, and the AIs that win that competition will get a prize as well. So you definitely want this prize. It's a very good prize, in my opinion. It's more than just a chocolate bar. It's 2 chocolate bars. No, it should be good. So if you have the time to make an AI for that, do enter, because it'll be really cool. And finally, on Friday, we have our linked lists practical exam. I know Friday, week 13, is your favorite time to have an exam for absolutely all of you, but we'll hopefully make it be a good exam. I'll put up some practice questions. It'll be good. Cool, and I'll put this up during the break. So, in terms of the final exam, there's 2 sections. There's a theory section and a practical section. The exam's going to go for 3 hours, so that'll be split half theory, half practical. And you can either be in the morning or the afternoon session. I'm sure you've noticed we can't fit you all in the labs at once. I should probably say that it'll be in the labs as well. So similar to the practical exam, same sort of environment, morning or afternoon session. So you can choose in a form whether you want to be in the morning, the afternoon, or you don't mind. And if you have a clash, so if you have another exam in the morning or afternoon, we will put you in the non-clashing session automatically, because we wouldn't try and make you be in 2 places at once. In terms of the topics, basically, we want to assess that you understand the topics in the course and that you can apply them. So, a summary of the topics, I guess, we have control flow, so loops and branching with if statements. Abstraction through functions and ADTs, data structures, including structs, ADTs, arrays, linked lists, memory and allocation, which is including things like using pointers, calloc, and free, and using linked lists to do things like implementing a list, stack, or queue ADT, and having an understanding of programming style. And so we're basically assessing that you can read code, you can write code, and you can understand code. So you can both write your own code to do something, or I guess that's the only thing you write code is to do something, to solve a problem or something. And you can read code that we've written and understand that code, and then maybe answer questions about it or say what's wrong with it or say what's good about it or whatever. So in the theory section, there'll be both short response and long response questions. You won't have a compiler, so you won't, we'll say something like write a piece of code to do this, we might, and you can't use a compiler to see if it works, you just have to write the code in the thing to make it work. Obviously, we're pretty understanding if you forget a single semicolon and your code doesn't compile, we're probably not going to give you 0 for that question because you don't have a compiler. But just testing that you can sort of write code conceptually and demonstrating that you understand the course concepts. So it's not going to be an exam like memorize every single thing we've done and tell me what rule number 5 of the style guide is. It's not that sort of exam, so it's that you understand the course topics, basically. In the practical section, you will have a compiler. You need to write actual code that actually works and runs. So it'll be the same environment sort of thing as we had for the linked list, sorry, the arrays, and we will have for the linked list exam. So you've got the exam environment, you can write code, you can compile code, you can't access your own files, and so on. You'll also have another chance to pass the array and linked list questions, if you haven't passed those yet, and there will also be additional practical questions. In terms of how to study for the final exam, so don't just cram the night before. Doesn't really work like that. But if you've been to tutes, if you've done the labs, if you've worked on the assignments, and you've consistently worked throughout the semester, you should be fine. This isn't designed to be a trick exam. We're not going to try and ask you all these little obscure parts of C that, do you understand the difference between this thing and this thing that even the tutors might not know? No. We want to assess that you can write code and that you can understand what's going on. If you've done the work throughout the semester, you should be fine. On the other hand, and you probably aren't here if this is you, but if you've skipped all the tutes and labs, or you maybe went to like the first 2 weeks and then thought, oh, the labs are boring and didn't do any more labs, if you didn't attempt the assignments, like, oh, you know, I'll just write this thing, oh, it passes some of the auto tests, whatever, it's fine. If you haven't consistently worked throughout the semester, I have some bad news, you can't learn programming overnight. You can't just, the night before the exam, go, I'm going to learn programming, and stay up all night and learn. It doesn't work like that. So if you haven't done any work all semester, probably you wouldn't be sitting here because you also would be at the beach or something rather than in the lecture. But don't panic. Do panic if you haven't done any work all semester, just a little bit. But if you've been here and you've been doing stuff, you should be fine. Cool. So that's pretty much all about the exam. In terms of revision stuff, you listed some topics that you want to go over, but I figured the best thing to do would actually be to ask you questions and then answer your questions rather than me saying, here's a reminder of how arrays work, because you might all know that already. So I went through and colored the topics, but I figured I'll actually answer questions. Isn't that cool? They got orange. Anyway, so looking at the questions, the first question is from Jishank. How do we start assignment 2? Is he even here? Wow, the ghost of Jishank. I'm sorry, Jishank, it's a bit late. We should really have started assignment 2 before now. But I guess on a serious note, if you are struggling with assignment 2 and you're not making progress and you're feeling kind of terrified and confused and don't know what's going on, ask on the forum, ask your tutor, ask me, ask one of the other tutors, come and talk to us. Like, we want to help you, basically. Oh, the question vanished. Oh, did Curtis get rid of it? Okay, the next top question, it's so cold. I disagree. I think it's a very pleasant temperature. I'm from New Zealand, where summer it's 23 degrees today, and this is as hot as it ever gets. But I mean, my fingers are going numb, so I feel for you. I don't know how to control the aircon. I don't think I can. Sometimes in lecture theatres there's a button over there, but I think those are lights. Should we panic? I already said no. How to write better tests for game.c? Good question. Queues versus stacks versus linked lists? Good question. When are the week 13 practice questions being released? Very good question. Hopefully today. Why is your hair so cool? I really like it. Thanks. I just woke up one day and had a rainbow on my head. I'm just going to answer the easy ones first. Are we able to switch times for the Friday exam? Yes. You can do that by emailing Mei Chang.
Right.
I do believe there was an announcement posted. No, I can't look. Computers. This one here. So email Mei Chang if you have any issues. She'll sort you out. It'll be great. Yes, what's the official due date for the assignment? Parts of it say Sunday, but the official date is Friday. I believe it's Sunday, unless it's not allowed to be Sunday, in which case it's Friday. But I will tell you before Friday. My understanding is that things aren't allowed to be due after the end of week 13, but I'm not sure whether that's Friday or Sunday. Is there anyone who wants it to be due on Friday and not Sunday? Just out of interest. I mean, if I were a student, I wouldn't, so. But I will definitely let you know about that. Okay, so I think that's all the easy ones. I'm going to assume that the 9 thumbs up for this top question means that you all want it the most. So, queues versus stacks versus linked lists. I'm not entirely sure what that's asking. Is it asking what the difference between them all are? What's the difference in when to use them? Very good question. I might plug my thing in. Curtis, could I get you to plug the thing in and get it set up so that I can not fluff around?
Oh, my hands are pretty cold.
Yeah, I should have brought gloves. I think it's just that, and then.
Oh, we're doing it this way, are we?
Yep.
Into the box. How complex is this thing?
So either plug it into this, or if that doesn't work, then plug it into the document camera. Is it actually that cold?
On the upside, I can passively call my laptop now. Show me videos of linked lists.
It's actually a good idea. So Curtis made a joke, but it's actually reminded me of a very good thing. So I don't know if you've seen, but in this very long sidebar, sort of down towards the bottom, there's a thing called video help. And this has a bunch of videos, so some that were made by, I think, some of the tutors last semester for various topics for COMP1511. So they have things like stacks and queues, ADTs, searching and sorting we're not doing, so you can ignore those ones. Memory allocation, pointers, structs and type def, and so on. So that's a good source of things to look at. There's also some on home computing. I thoroughly hope that you have all worked out how to write code from your home computer or your laptop so far. It's a very useful thing to do. And there are some videos on debugging. So I do highly recommend having a look at those. There are also some cool ones. Do you remember that time zone video I played with that guy just complaining for 5 minutes about time zones? So there are some other cool ones from that channel that are actually not just complaining and are covering things like linked lists, which are quite cool, and I might put the link to up. Okay, continue. Any minute now. Is it going to work? Yes. Okay. Record. Sorry, the recording app just updated, so I have to open it and do a thing. Okay, record. Perfect. So, queues versus stacks versus linked lists. First of all, the difference between linked lists and queues and stacks. Linked lists are a way of creating a queue or a stack. But similarly, we could also do that with an array or with something else if we wanted to find another way somehow. So, linked lists themselves are a tool for building things. They're a way we can do things like store a list of data, store a sequence of data. Whereas queues and stacks are things that we can create with linked lists or with an array. So conceptually, a linked list is just, we have our nodes and our arrows and so on. Whereas a stack or a queue are things we can make with linked lists or with something else. And so we refer to them in sort of an abstract sense. We could make a stack ADT or a queue ADT, wherein it doesn't actually matter how we store it underneath, just that we can do these operations on it. And so a stack is like a stack of pancakes. These are some very accurate pancakes. You can only add things to it. You can only add things to the top, and you can only take things off the top. Like, if you try and take something off the bottom of your stack of pancakes, it's really hard. I tried the last time I made pancakes to prove to myself that it was a good stack example, and you really can't. So conceptually, a stack is just a data structure that we can put things on top of each other and then take things off the top of each other. Can anyone think of a reason that that might be useful in terms of programming or in terms of making to work with? Stacking chairs? That's a very good physical example. Can you think of any programming examples? Any reason why you should do this aside from because we tell you to? Have a think about it. Oh, yeah? Stack frames. So that's a very good point. Or a very good thought. So conceptually, yes, a stack with a stack frame. Perfect. In terms of implementation, you wouldn't implement a stack frame with an ADT on the basis that your ADTs need to be running in code which needs to have stack frames. But you could simulate, I guess, a stack frame with that. Cool, very good thought. Yep. You heard that right? You heard that right? Oh. Anyway, there was a sound. Yes, so he said for when we only need to add things to the top and take things off the top and never anything else, it means that both it's easier because we can only do those limited things and we can't accidentally take things not off the top. Can you think of an example in your recent assignments that involves only taking things off the top of something and never... Yeah, discard file. Discard file is adding to the top. Deck is taking off the top. Yep. How many of you have used a stack explicitly to implement your deck or your discard pile in your game? Anyone? Oh, a couple of you. Out of interest, how many of you are using linked lists to represent your discard pile or your deck in any way? How many of you are using arrays? Just out of interest. Okay, nobody admits to it. If you are, and you go to spots, you will see that I create decks that are 30 million big. Your arrays should not be 30 million big. Coders will be sad. You'll break spots. Coders doesn't care, it'll just be your thing that's broken. Cool, and then queues are the same thing, but not the same thing. So rather than, we call a stack a LIFO, last in, first out. The last thing that was added is the first thing that's removed. Whereas a queue we'd call a FIFO, first thing in, first thing out. So that's something like if you're queuing up to buy something at a store, the first person who joins the queue is the first person who'll be served, and so on. Anonymous person who asked this, does this answer your question? Anyone who had questions about it? Yep. Very good question. Yeah? Did you have another question? Okay, one question at a time. So the question was, in terms of actually implementing a queue, in terms of the null pointer and stuff like that, how would you do it? So the answer is, it's up to you. Everything is up to you. But the way I do it is something like this. So I've got my list, and that points to a node, and that points to another node, and so on and so on. When we want to add something, we want to add it to the end, and when we want to remove something, we want to remove it from the front. It's up to you whether the end is this one here, and then the front is this one here, or if you want this one here to be the front, and this one here to be the end. It doesn't matter in the sense that because it's an ADT, you can choose how to implement it yourself, as long as you pick one that is always the end and stick with that being the end. I would say if you're frequently inserting things and not removing things, oh no, let me ask you that question. Does it make a difference if it's if you have the front and the end or the front and the end? Easy to add something to the end, as in the bit next to the null? So how would you find where the end of the list is if you wanted to add or remove something from the end of the list? Yeah? You could have a head pointer and a tail pointer. Here we go. Oh man. How long has that been doing that for? Okay, that's good. There we go. So yeah, we could make a head pointer and a tail pointer. It doesn't make a difference unless it's harder to insert at the end because we don't have a tail pointer, in which case decide which way you want to be doing more often. But basically pick one to be your start and one to be your head, one to be your tail, or one to be your front, one to be your back. If you're adding something, so we'll say that this is the front. Whoa. And this is the end. So the way we would do this, if we were adding something into the queue, we would add them at the back of the queue. So that would look something like make a new node, and then update the pointer of the previous end one, which is actually this one here, to point to this new node rather than null, and then make this one here point to null. And if we have a tail pointer, make this one here be our tail pointer. Does that make sense? And then adding something, removing something from the front, we'd just go, okay, here's the thing at the start of our list. We're going to take this out of our list and make our list head point over here instead. Cool. Does that make sense? Any other questions? Okay. I'll hold off on beta tests because that is a slightly longer answer. Is there any difference between something star and star something? I'll do this in VLab because my hands are a bit cold to write finally. Okay. let's take my list template. Okay, this will do for now. So, the difference between something star and star something. So, first of all, what are the two that I can think of times where we'd use stars in programming? One of them being multiplication. Yeah, one of them being multiplication, one of them being pointers. Cool. In terms of pointers, there are sort of two directions that the star can be on. We could have something like node star new. We can have something like new, I'll make them be chars. Char star blah, and something like star blah. So when we write it like this, technically this could be in the middle, or it could be stuck to one of the ends of it. This char star here is saying that we have a type that is a pointer to a character. And so in C's definition, I guess, of the valid syntax, we could write it like this. We could write char star space blah, saying that it's a pointer to a character. We could write char space star space blah, still a pointer to a character. In this course, we write it like this, char space star blah. They're all equivalent syntax. But the reason we do it this way is because it's really clear that blah is a pointer. We can do something like this in C. We could go int A, B, C, right? And now we've got three ints called A, B, and C. We could do something like char star A, B, C. If this line makes three ints, what does this line make? 3 pointers? Does it make 3 pointers? Yeah, 1 pointer. It actually just makes 1 pointer. This one here becomes a char star, and these ones just become chars. And so, to avoid this sort of confusion, we put the star next to the variable name. And so now it still does the same thing. There's still just 1 pointer, but it's easier to see that there's just 1 pointer. And then doing something like the star something here, if something is a variable, this will dereference the variable. So this will go to the variable and let us access the thing that it's pointing to. Are there any other questions about that? Okay. Can we have assignment 0 and 1 marks back, please? Yes, very, very soon. Very, very, very soon. Very, 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 very soon. Hopefully tonight. I say that a lot. They're all on my computer just about ready to go. I'm very, very sorry for the delay in that. Like, it's been completely ridiculous, and you guys are probably feeling really annoyed. I'm feeling really annoyed with myself for not having it done before now, so I am very sorry about that, but they are almost completely ready to go for assignment 0. And assignment 1, not quite as ready to go, but almost ready to go. Could we use size of node rather than size of struct node? Size of node versus size of struct underscore node. Yep, very good question. That'll be an error because it's not a struct. So, looking at these things here, who thinks that they're all equivalent? All of them did the same thing. Who thinks that some of them are equivalent, but some of them aren't? Who thinks that they all do different things? Who has no idea, but wants to raise their arm? Very good. So, what is a capital N node? It's a pointer to a node. What size are pointers? Yeah, there might be 4, there might be 8, but they are the size of 1 pointer. What size is a struct node? Yeah, 1 node worth of stuff. I'll put it down here so we can see it again. So a struct node is going to be one actual physical node worth of things, one circle worth of things. In this case, it's got an int value, which might be 4 or 8 bytes, and a node next, which might be 4 or 8 bytes. But importantly, one thing we do know is that it contains both a node pointer and something else. So there's no way that this can be big enough to fit. Sorry, there's no way that a node pointer by itself will be big enough to fit an entire node struct. So when we say size of node with a capital N, size of node, we're saying the size of a pointer to a node. When we're saying size of struct node, we're saying the size of the struct that is a node struct. What about size of node? The size of both something in the struct? Yep, the size of all the elements in the struct. So the same as this one here. The reason for that is we have our struct node. This bit here makes up our struct node, the highlighted bit. And we also have our type def. The syntax for type def is the word type def, everything up until the very last word, and then the last word. So this is saying, I have a struct node, which looks like this, struct underscore node, and please type def so that a node with a lowercase n also is the same as a struct node. Does that make sense? So yeah, node with a lowercase n, struct underscore node are the same, node with a capital N, size of a pointer, not the same size as a struct. Cool. Yep. That's a very good question. So when we're callocating memory for a game, what should it look like? Yep, so with a linked list, do we just calloc the header, or do we calloc an actual node? I should have new list function here. So when we're making a new list, remember lists have both the list struct and nodes. So to calloc a list, to calloc the oh, the whole thing's gone. Oh well, I'll fix it in the break. So to calloc a list, we have to calloc the square that is a list struct. So it's going to have the node pointer head and maybe a tail pointer and maybe a number of items and maybe anything else you want. So that needs to be callocing the size of the list struct. And then for a linked list, that's enough. We just make this, and then as we make new nodes, we calloc new nodes. And we can see that down here. To make one node, we calloc one node, we add that to our list, and so on. In terms of your game struct, it'll probably look something like this. Struct underscore game. Game. Probably something more complex than this. You might have something like a deck called deck, and a discard pile called discard pile. I'm sorry, my hands are really cold. If you've made a type called deck and a type called discard pile, discard pie, you might have some way of storing players, so you'd have like players 4, because it's 4 players. Other things, we have like the direction, so you might have like direction, current direction. What other things might you have in your game struct? Maybe like in current player. Some other stuff. So when you're allocating memory for a game struct, you want to allocate memory for this game struct itself here, and also for everything inside that needs to be allocated. So in this case, we type def the game struct, which is going to be, this might be a pointer, this might, well, it's capital D, it'll be a pointer, pointer, pointer. Lowercase d means this will be an actual thing inside the struct. Int will be an actual thing inside the struct. And then you might have something like a new deck function, which takes some game or whatever. And this will, if you have some sort of deck data structure, What might you have in here? Like int num cards, maybe. You might have a list of cards, you might have something like that in your deck or so on. So then when you are making a new deck, you'd need to allocate the memory for this, and then also allocate the memory for your list of cards if you're storing a list of cards, for example. I have a very good diagram of this. I'm not sure how many of you will have read this, but during the quiet week, I wrote up a thing on the image struct, if you can read my handwriting. So we've got a struct image which has the width and the height as ints, and then a pixel star array, so a two-dimensional array of pixels. And so that looks like we have an int that's 4 bytes, an int that's 4 bytes, a pointer to a pixel that's 4 bytes. So we can calc sides of image with a lowercase I, and that gives us this struct with these 3 fields in it, 12 bytes of memory. But then the pixel array is reading this. It says array is a pointer to a pixel, which is effectively going to be a 2D array of pixels. So we'd need to allocate the rows, make our array be height number of pixel pointers, which would look like this. And then to allocate each of the rows, we would want to go through each of these pixel pointers here and allocate a row in there. I'm just skimming through this because you can read it on your own time, but it'll look something like this. So we have our column of pointers points to our row of pointers, and so on. I highly recommend reading through this. It's beautiful, if I do say so myself. Yep, you can make one pixel be green. But this hopefully sort of explains how to go about allocating memory for a struct that contains things inside it. Okay, are there any more questions on that for now? Two questions at once. First question first. What's the difference between callocating... Yeah, if there is no difference between this and this, why would we do one and not the other? So, there isn't really a reason to do one over the other that I can think of. Coders can think of a reason to do. Yep. So Curtis's answer is, if you're using list a lot, it helps to think of it just as we have this type list, and you can sort of abstract away the fact that it's a struct list. Yeah. There is no technical difference between them. The one time that it matters is when we're doing this sort of thing here. We can't type def a list pointer until we tell it what a list is here. Or down, yeah. And similarly, we can't like use a capital N node pointer until we've got this thing here. So it's sort of a circular thing. Did you have a separate question? Okay. Are there any more questions, or should we take a break? A break, okay. So I have a fantastic video from the My Experience team to show you. Or maybe I don't, because it's frozen. Here we go, click here. I hope you're excited. So I'll play this 1 minute and 1 second video, and then we'll have a break of 10 minutes. During the break, you should stand up and like wave your arms around to get blood flowing so that you're less cold. so that you can keep on thinking and keep on typing. If you haven't filled out my experience and you want to in the break, that would be good. It would be a good time to do it. And otherwise, so, 1 second.